Hello everyone and welcome to Growing 2.3. Today's learning target, I will be able to write an equation for an exponential relationship from its graph or description in words and solve problems involving exponential growth. Okay, those are the key words for this investigation. We have been using tables to come up with our equations for our exponential relationships. This time we're going to use a graph to do that. Now, we were taking table information and making graphs. Now we're given a graph. Maybe we want to make a table. I don't know. Might be one of the solutions. You may just be able to look at it, find a pattern, and come up with your equation. So use whatever problem-solving method you want to, but think about how we've been working so far, and maybe we do that in reverse order. When we get done, our 2.3 ACES questions are 9 through 13 and 25 through 28. So this time we are studying snake populations. Yay! Interpreting graphs of exponential functions. So, garter snakes were introduced to a new area 4 years ago. Population is growing exponentially, and the relationship between the number of snakes and the year is modeled with an exponential function. So, down here on page 31 of your textbook is this graph here, growth of garter snake population. What it asks you to do down here is that we want to find the snake population for years 2, 3, and 4, and then use that pattern in your answers from part 1 to estimate the population in year 1 and explain your reasoning. I also want you to explain how you can find the y-intercept of the graph. Well, I know it's hard on this graph to see, like at year 1, what that value is, and it's even harder to see what the possible y-intercept might be. So even though it's difficult to read the graph, can we record which points are easy to read? Can you find those? Can we record them? And then what is the growth pattern for those 3 years? Okay, think about that. Look at those 3 years, 2, 3, and 4, and see if you can identify what the growth pattern is, and then try to work backwards. Take that growth pattern and work back to year 1. Okay, if we reverse that growth pattern, what would it be in year 1? And then what would the population have been in year 0, or what would your y-intercept have been? So those are things that we kind of want to work on and try to accomplish in this 2.3, because we've been taking tables, full values of tables, graphing them, and then coming up with equations. Well, now we're given a graph, table our information, try to find our pattern, and then work backwards to be able to complete the table with the other years. B, explain how to find the growth factor for the population. So how did you come up with that based on the pattern you saw in the table? As we said, write an equation. And then in what year is the population likely to reach 1,500 snakes? So it's going to be interesting coming up with your equation this time. It might be a little bit of a challenge, or maybe the pattern is clear to you and you come up with your equation quite easily and can do the prediction here in part D. So I think this will be a fun challenge. Look forward to your questions in the classroom. And the ACES questions we'll be doing in the classroom will be 9 through 13 and 25 through 28.